Another calculation we can make when we know the chemical formula of a molecule or a compound is percent composition. So we can go through and see what percentage of each element is contained within that molecule or compound. A lot of times students are very confused about percentages. Percentages are simple though. It's part over whole times 100. That's what a percent is every single time. So it is the part of what you're looking for, so percent of whatever. It's the part of what you're looking for over the whole thing times 100. So applied in this sense, to find the percent element in a compound, you would take the molar mass of what you're looking for divided by the molar mass of the whole compound. All of that times 100, and that gives you the percent element in that compound. So we're going to be dealing with molar mass here, so it gives us time to practice that. And the example question I have here is find the percent composition or the percent oxygen in sodium nitrate. Now, I did give you the formula here, but I don't have to since you know how to write formulas correctly. So the easiest way to start with a problem like this, or percent composition, is to go ahead and find the molar mass of the whole thing. This is what you did for homework. So sodium nitrate has 1 sodium, it has 1 nitrogen, and it has 3 oxygens. Now, the molar mass comes from the periodic table, so sodium is 22.99 grams per mole. Nitrogen's 14.01 grams per mole, and each oxygen is 16 grams per mole. Again, that's 2 decimal places from the periodic table. That's where I got those numbers. Now, I'll make this adjustment here because I did have 3 oxygens, and I add that all together, and I get 85 grams per mole. That is the molar mass of sodium nitrate. Okay. The question asks for the percent oxygen in the compound. So to find the percent oxygen, I need to get the mass of all the oxygens. I did have 3 of them. So that's 3 times 16, which gives me 48 grams per mole. Over the mass of the whole thing, which is 85 grams per mole. And then all of that times 100. So when I calculate this, I end up with 48 divided by 85 times 100. And so I'm not real picky with sig figs here. Grams per mole cancels out, so it'll just be a percentage for your answer. Let's just take it to 1 decimal place. 56.4, rounding rules, 0.5% oxygen in that compound. So it's over half oxygen. Now, if I wanted to find the percent nitrogen in this one, let's percent nitrogen. So to find the percent nitrogen, then I would take the molar mass of what I'm looking for, and I'm looking for nitrogen. So there's only 1 nitrogen, so that would be 14.01 over 85, which is the molar mass of the whole thing, 0.00. All of that times 100. And so 14.01 divided by 85, and then times 100, is 16.5% nitrogen. Now, oftentimes in the question, it will just read, what is the percent composition of sodium nitrate? When it says something like that, that means they want every single element. So you would go through, find the percent oxygen, you would go through, find the percent nitrogen, and then you would need to find the percent sodium. And you could do that in the exact same manner, or since it's the last element there and it makes up the whole thing, you could say 100 minus 56.5 minus 16.5, and that will give us our percent sodium. 100 minus 56.5 minus 16.5. That will give us the 27% sodium, because it is out of 100%. Or you could do it the exact same way. It would just be 22.99 on top over 85 times 100, and that should give you this exact same answer. All right, so that's how to find the percent of an element that's in a compound. We can expand this a little bit further, and we can talk about the percent of water in a hydrate. The way we find the percent water in a hydrate is going to be the exact same way. It's the molar mass of what you're looking for over the molar mass of the whole compound. So I'm going to use one from the homework page, the hydrate that we have here. So percent water in copper sulfate heptahydrate. There we go. And so to find the percent water, it is going to be the mass of all of the waters. Well, in this case, I have 7 waters in here. Now, you can have the molar mass of water memorized, and we calculated it earlier in this chapter. Otherwise, or you can just calculate it now. You've got 2 hydrogens and 1 oxygen. So the molar mass of 1 water is 18.02 grams per mole. But I don't have 1 water in this hydrate. I have 7 waters in this hydrate. So what I'm going to do is it's going to be 7 times the molar mass of 1 water. That gets the mass of all the waters over the mass of the whole thing, including the waters. So you would find the mass of the copper sulfate, or copper 2 sulfate, and I got 159.62. And then you would add the mass of those 7 waters, so 7 times 18.02. And for a total mass of 285.76 grams per mole. That's the molar mass of the whole hydrate. Grams per mole cancel it out, all of that times 100. And when I do this calculation, 7 times 18.02 divided by 285.76 times 100, I get that this thing is 44.1% water. Now that can be significant if I'm purchasing things, and chemicals are usually purchased by weight. I'm paying for 44% water, which is almost half. So that's an important thing to keep in mind. So we can use it to find the percent water in a hydrate. We can find it to use it to find the percent sulfate in a calcium sulfate. So it can be used lots of different ways, but the general formula is always the same. Part over whole times 100.